Okay, notes 5.1 are on one variable inequalities. At the top of your paper, it shows you inequality symbols. And what I would like for you to do, please, is fill in these symbols. So please press pause, fill them in, and then come back to me to see how you did. All right, now you should have that A is less than or is less than B for the first one. The second one, you should get A is less than or equal to B. Then you should have gotten A is greater than B. And then finally, A is greater than or equal to B. All right, so let's say you had an example where it said that X equals 3. Okay, when you know that X equals 3, that means that you have one solution, and that one solution is that X equals 3. Okay, but in this example right here, it says that X is greater than 3, which means that you have multiple possible solutions. X could be anything as long as it's bigger than 3. So you have infinite choices. It could be 4, it could be 5, it could be 20, it could be pi. It doesn't matter as long as it's bigger than 3. So it's impossible for me to list out all the possible answers. So what I would do instead is that I would shade in all the possible numbers. So how do I graph an inequality? Step number 1, always draw a number line. So let's go ahead and draw a number line in. Okay, so here's my number line. And I'm going to put in about 5 dashes so that way I can get a good representation of what's going on. And I'm going to say that this is 3. I'm going to put the 3 right in the middle. I'll put 2 here, 1 there. And then I've got 4 and 5 here, okay? And then it says draw a circle around the number. So I'm going to draw a circle around the number that X is related to. It says X is bigger than 3. You're going to use an open circle for less than or greater than statements, and you're going to use a closed circle for less than or equal to or greater than or equal to statements. Now, why? Well, the whole point of shading in all of my numbers is to see what works. So everything bigger than 3 will work. So I would shade in everything after the 3. However, 3 does not work because X is only bigger than 3. It's not greater than or equal to 3. So I have to put an open circle to show that it could be anything that's close to 3, but not 3. Well, why can't I just put a circle next to the 3 instead of on the 3 and then shade it in? Well, the reason why you can't do that is if you were to do that, like let's say I put 3 here, and then I were to put a circle right here, there's still going to be some space between where the 3 is and where the circle is. Even if you can't see it here, if you were to zoom in on it, you would still be able to see that there's a space between them. So it's any possible value that's somewhat that is greater than 3 but not exactly equal to 3. So what's the point of drawing a number line? Well, we have infinite solutions. So since there are infinite answers, we represent them by shading, okay? Hopefully that makes sense to you. All right. So let's go ahead and do this graphing right here. Number 1, X is less than or equal to 5. So what I'm going to do is I'm going to put a line right on 5, and then I'm going to go a little bit below 5, and I'm going to go a little bit above 5, okay? And I'm going to have a closed circle right on the 5 because X could be equal to 5. And then I'm going to see what values are less than or equal to 5 that will work. Well, I know that 4 works, 3 works, 4.99999 works, right? Anything less than 5 will work. So I'll shade in everything to the left of this 5. All right, and number 2, let's do this one. Well, I'm going to put a line right here and represent this as -3. Now, don't forget the negatives work backwards, so be really careful as you're shading this in. Okay, and if X is greater than -3, I'm going to put an open circle on -3 because it can't be equal to -3. And everything that's bigger than -3 will work. -2 works, 5,000 works. All of those numbers are to the right of -3. Now, in question number 3, 4 is less than X. This one is a tricky one. So I'm going to put 4 here, 5 and 6, and then I'll put 3 here and 2 there. If 4 is less than X, think about this logically. That means that I can conclude that X is greater than 4. Okay, so then I'll put an open circle on the 4 and then shade in everything to the right of this value right here. Okay, and then the last one, x is at most 15. Well, if x is at most 15, that means that x could be 15, right? So I'll have 15 here. I'll put 16, 17, 14, and 13. Okay, so if x could be 15, then I'll put a closed circle on the 15. But if x is at most 15, that means that anything above 15 will not work, which means that x is less than or equal to 15. That's what this statement right here means. X is less than or equal to 15. All right, you guys, I want to skip question number 5 for right now, and I want to look at number 6. I want to solve the inequality and then shade in all possible values of x that could work, okay? So in order to be able to do that, I need to solve for x to begin with. So in order to solve for x, I would subtract x from both sides. Get rid of this x, get rid of this x. I would end up getting 4x minus 7 is less than or equal to 9, okay? Then I would add 7 to both sides, so I would get 4x is less than or equal to 16, which means that x is less than or equal to 4, okay? So I'm going to put a 4 here, a 3 here, a 2 here, a 5 here, and a 6 there. I'm going to use a closed circle because x could be equal to 4, and it's going to go to the left. So I would shade into the left. Okay. Now, any value that's in the shaded area right here will work. Okay. So I'm going to choose a random value that's in the shaded area. I'm going to try 1. So watch what happens if I replace 1 in for x. So it would be 5 times 1, right, minus 7 is less than or equal to 1 plus 9. So I'm going to fill in my value of x is 1. And I'm going to evaluate my two sides of my inequality. So I get 5 minus 7 is less than or equal to 10. So I get negative 2 is less than or equal to 10, which is a true statement. Negative 2 is less than or equal to 10. So that shows me that 1 is an answer that works. It doesn't show me that my answer is for sure 100% correct, because the only way I could do that is to check every single solution, which is impossible because there's infinite solutions. Okay? But it definitely shows me that my answer is promising. All right. Okay. So I want to go back to question number 5, and I want you guys right now to think about what the first step would be in order to solve this inequality. I would divide both sides by negative 6. Okay. So when I do that, when I divide both sides by negative 6, don't write this down. I want you to just watch what I'm doing, and then I'll tell you when to start writing stuff down again, okay? So you would end up getting z is less than negative 7, okay? So let's let's graph out our information. So we've got negative 7, negative 8, negative 9 on the left, and here I would get negative 6 and negative 5, right? So then I would shade in the circle the negative 7, but I wouldn't shade it in, and then I would shade everything into the left, right? So if I were to do that, any one of these numbers in this area works. So I'm going to try negative 9. I'm just going to randomly, arbitrarily choose the number negative 9, okay? So I'm going to say 6 times negative 9 is less than 42. I want to see if it works or not, okay? Well, 6 times negative 9 is, negative 6 times negative 9. Negative 6 times negative 9 is positive 54, which is supposed to be less than 42, but that is not a true statement. It didn't work at all. So here's where we have to be really careful. Let's look right here. Important. If you have to multiply or divide by a negative number, you have to always blank, 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 blank. You always have to change or switch the inequality sign. All right, so what I want you guys to do by the time I see you next time in class, where it says y right here, you need to think about why that's true. Why do I have to switch the inequality sign if I multiply or divide by a negative number, but I don't have to do it if I add, subtract negative numbers, or even if I multiply or divide by positive numbers? That's something we're going to discuss next time we have class, so you need to really think hard about that before I see you in class, all right? So let's correct this. Let's do this appropriately. So I'm going to divide both sides by -6, just like we said. That step was correct. So if I divide this by -6, I divide the other side by -6. Because I divided by -6, I gotta switch my inequality sign. So it was originally less than, now it's greater than. So then I'm going to put -7 here, -8, -9. Here is -6 and -5. So then what I'm going to do is I'm going to circle my -7, but I'm not going to shade it in because it's not equal to -7. And then I'm going to shade everything to the right of -7. Now let's try this again and see if it works. So if I were to plug in randomly, I'm going to choose -5 as my number that's I'm going to plug in since it's in the shaded area. So I'm going to do -6. Sorry, I don't know why it keeps doing that. Ooh, that's no good. Okay, so I end up getting -6 times -5, right? Is less than 42. So then I end up getting 30 is less than 42, which is a true statement. So it does work when you switch the inequality sign, and it's really important that you make sure to do that. All right? Okay, so now let's skip down to question number 7. 2 more problems and then we will be done. Number 7, if 3/4 of a whole number decreased by 8 is at least 3, what is the smallest number that will satisfy the solution? Well, we've got a word problem. So remember, everything we learned about word problems applies. First of all, you're going to underline or highlight your key information, okay? So I'm going to underline 3/4 of a whole number decreased by 8 is at least 3. Okay, and I want to figure out what is the smallest number that will satisfy the solution. Okay, so now I'm going to solve my inequality, okay? And I'm going to multiply everything through by a common denominator of 4 so I can clear my fractions. So I end up getting 3x minus 32 is greater than or equal to 12 because everything times 4 turns into these numbers. Then I would add 32 to both sides, so I would end up getting 3x is greater than or equal to 44. Okay, then divide both sides by 3, I end up getting x is greater than or equal to 44/3, which would end up being 14 2/3. Okay, now x could be equal to 14 2/3 because it says greater than or equal to 14 2/3 if the number did not have to be a whole number, but it says it has to be a whole number. So the smallest possible whole number that will work will be 15. Now, a lot of people will say x is greater than or equal to 15. That is not your answer. This is your answer to your inequality, this right here. But the answer to the question, the whole number that we're looking for, is 15. All right, let's look at number 8. Stephen said that he would spend at most $450 on a snowboard and a helmet with speakers. If the price of the snowboard was $100 less than 4 times the price of the helmet, find the highest possible price of the snowboard. Okay? So first of all, I have to ask myself, how many things do I not know? Well, I don't know the price of the snowboard and I don't know the price of the helmet. So that means I'm going to have to write 2 let statements. Now the question is, which one do I need to know first? Well, the snowboard is based on the helmet, so I need to have the price of the helmet first. So I'm going to say let the helmet price equal any variable you want. I'm going to say equal h, okay? And then I'm going to say let the snowboard price equal, what does it say? It's 100 less than 4 times the helmet. So I'm going to take 4 times the helmet and subtract 100. Okay? And it says that Stephen decided that he would spend at most $450. So that means that he will not spend any more than $450. He's okay with $450, but nothing more than that, okay? So when you go to the store, though, you have to pay for your helmet and the snowboard. So I'm going to pay for the helmet and I'm going to pay for the snowboard, and I want to spend either $450 or smaller, so less than or equal to $450. Okay, then I would combine like terms, so I get 5h minus 100 is less than or equal to $450. So that means that 5h is less than or equal to $550. right? So that means that H is less than or equal to 110. Okay, so that's the price of the helmet. I'm going to say the helmet is $110. Okay, so to figure out the price of the snowboard, I just plug in 110 in for H, right? Minus 100. So I get 440 minus 100, so I get 340. Okay, so I'm just going to write a little quick sentence to say that the helmet is $100 and the snowboard is $340. Okay, and then I'm done. Have a good day.